negative g or negative mg. The weight of this object is negative mg. It is directed downwards, where m is the mass and g is the acceleration caused by the force of gravity. So here, when it falls under the action of that net force, which is m times g. Well, the negative sign indicates that the direction of the weight of the force is downward. Mass is a scalar quantity. Mass of an object has no direction. It is simply a measure of the inertia of that object. We measure it in kilogram, whereas weight is a force and we measure it in Newton. Now, I measured my mass about a couple of minutes ago. My mass is 54 kilograms. All right? My mass m is 54 kilogram. Can you tell me what is my weight? Is my weight the same as this? Can I say my weight is 54 kilogram? Well, that is what many people say these days, but that is wrong. 54 kilogram is the unit of mass. That is my mass. My weight will be 54 kilogram times negative g. That will be negative 54 g. My weight W will be negative 54 g. If I can measure this g, then I know what my weight is. What is the unit for measuring my weight? Weight is a force. The unit is Newton. So you can only report your weight in Newton, not in kilogram, not in pounds. Weight is a force and its unit is the Newton. I hope you understand and don't confuse it again. Alright, let's now talk about the third law of motion. Now, we talked about two laws now. The first law enabled us to define force. We said force is something that changes the state of rest or the state of uniform motion of an object. The second law enabled us to measure force. Well, before we go to third law, let me say something about the acceleration caused by the force of gravity. Now, that can be measured very easily. What all you need to do is drop an object, measure the time taken for it to fall to the ground, and you can calculate. Now, you know that the time taken, do you remember this? The time taken for an object to fall through a height h is square root of 2h over g. We talked about that in projectile motion. That means t squared equal to 2h over g, or g equal to 2h divided by t squared. So in order to measure acceleration due to gravity, what all I need to do is to take this basketball to a fairly high place, and I start a clock at the same time, drop it. When it hits the ground, stop the clock, measure that time, and measure the height through which the ball fell. You can calculate the value of g. G equal to 2h over t squared. Now, it is being calculated, and you will actually do that in the labs. And its value has been obtained as 9.8 meter per second squared. So if G is 9.8 meter per second squared, can you tell me what is my weight? My mass is 54 kilogram, and therefore my weight will be 54 times 9.8 Newton, will be 54 kilogram times 9.8, which will be approximately, I think, 530 Newton. So my weight is approximately 530 Newton. You can see I haven't used the negative sign here. Well, because I was only interested in the magnitude. But when you use G for calculation, for problems, it is a vector. Weight is a vector. So you must use the direction there as well. Okay. Alright, let's go back and talk about the third law of motion. Now, what does the third law talks about? It's a very common law, many people know it. Now, the third law states that forces always come in pairs. Well, forces always come in pairs. What are the force pairs in this case? I'm applying a force upward and this mass is pulling me down. There is a force pair here. Well, the law says all forces come in pairs. What does that mean? Now here I have a girl who is meditating. What are the forces acting on her? Can you tell me? Are there any forces acting on her? Certainly yes. Well, first of all, she has a weight. What is the direction of weight? Weight is always a force that is acting vertically down. So there is a force that wants to pull her down. Now why isn't she going down? She's sitting on a platform actually. She's not in air. Well, the platform will apply a force upward. So, if the weight is the only force acting on her, she will be falling freely with an acceleration negative g meter per second squared. Well, since she is not doing that, there is another force acting on her, keeping her at rest. What is that force? This is the force applied by the floor directed upward on her. And this is called the force of reaction. And we also call it the normal force. What is the meaning of the normal force? It means that force is at right angles to the surface where she is sitting. You see that? That is why it's called the normal force. A normal is a perpendicular. So, when this mass is sitting on my hand, what are the two forces there? The weight of this mass is acting vertically down, and the force of reaction applied by my hand is the normal force vertically upward. And the magnitudes of these two forces are exactly the same. So you got the weight acting vertically down and the normal force acting vertically up. Now look at the force pairs on the box when the box is sitting on the floor. Here's a box. What are the force pairs on that box? The weight mg is acting vertically down and the normal force N is acting vertically up. Now tell me, what is the net force on the box? The net force on the box is the sum of these two forces. N is a positive force, mg is a negative force. Therefore, the net force is N minus mg, And since there is no net force on the box, we can say N minus mg equal to 0. Or